So now we're going to move on to question 3. The question 3 is also under capital budgeting or investment appraisal. So let me read it. So it says the following information relates to two exclusive projects. Cost of capital 10%. Then we given the cost. So for plant 1, the cost of it was 100. So it is 000, so which is 100,000. Then plant 2, you have 60,000. Then they've given us the expected annual profits. So for year 1, we have 29,000, which is 29, and year 2 was into brackets 1, then year 3 2. Then for the plant, we have 18 into bracket 2 and 4. Then they've given us the residual value to be 7 and 6, which is 7,000 and 6,000. Now required, calculate the payback period. B, net present value. C, internal rate of return. And D, recommend the plan to purchase and explain why NPV should considered over IRR. All right. So for most of these questions, they're usually going to give you the cash flow. So for the payback period, we would have just started. But remember this one, they've given you the expected annual profit, and we need the cash flow. In investment appraisal, we don't deal with annual profits, especially when it comes to payback periods. You calculate it on the cash flow. You get it, not on the profits. Calculate it on the cash flow if you want to see how much you're actually getting, not on the profits. So the first thing you have to find is the cash flow. The cash flow is the profits plus depreciation. So cash flow is equal to profits plus depreciation. Yeah, so the cash flow minus the depreciation is what will give you profits. Remember, when they give you the cash flow, when you want to find the profits, it is the cash flow minus the depreciation. So if you have the cash flow, which is cash flow minus the depreciation is equal to the profits. So if you want to find the cash flow, to be just the cash flow is equal to the profit plus the depreciation. So just do a change of subjects, yes. So they've given us the profits already, the expected annual profit. So now we need to calculate for the depreciation. The depreciation was not given. So what is depreciation? The formula for the depreciation is equal to cost of assets. Cost of assets minus the scrap value or the residual value. So let's use residual value over the useful life of assets. This is the formula for the depreciation. Now, what is the cost of assets? The cost of assets so let's do it for both years so that we can just work it easily. So let's start with plant 1. So for plant 1, the cost of assets is 100,000 cedis. So you can do it 100,000 minus the residual value. The residual value is 7,000. 7,000, which is your residual value, over the useful life of assets, which is 3. Yes, because it's only 3 years that are there. So 1, 2, 3. So now let's do it on the calculator. So we have 100,000 minus 7,000 over 3. We're getting 31,000. 31,000. So you can see for plant 1, the depreciation is 31,000. This is the annual depreciation. What's calculated for is annual. So the annual depreciation is 31,000. Now for the plant 2, the cost of the assets, which is the one in brackets. So the cost of assets will be given to you first, which is the one in brackets. So 60. So 60,000. It's 60,000 because at the top is 000. So when you see 000 at the top, it means if it's 6, it becomes 6,000. If it's 60, add the 3 zeros. If it's 600, add the 3 zeros, like that. So 60,000 minus, let me clean this. So 60,000 minus the residual value. The residual value for that one was 6,000. You wrote 6, so it will become 6,000. You add the 3 zeros over 3 as well. When you turn the calculator, what are we getting? So you are getting 60,000 minus 6,000 over 3. I'm getting 18,000. 18,000. So now we've got the annual depreciation for plant 1 and plant 2. And the A says you should calculate the payback period. So now that we've got the cash flows, you can calculate the payback period. You get it? So now let me just write them at the top so that we don't forget. So annual depreciation, let me do AD for plant 1 is equal to 31,000. 31,000. Then plant 2 is equal to 18,000. So the annual depreciation for plant 1 is 31,000 and plant 2 is 18,000. So now since we have the depreciation, we'll just add the profit and the depreciation to get the cash flow. Then we can calculate the payback period. So let's clean this one. So now we are going to calculate for the cash flow. So we'll add the profit and the depreciation. So the profit has already been given to us in the question. And the depreciation is here. So for plant 1, we have 31,000. Plant 2, we have 18,000. So let's start. So we have year 1, 2, and 3. Then we have our profits. So the profit they've given us to us. So for plant 1, to the profits, year 1 is 29. So 29,000. Then year 2 is, so anytime you see anything in brackets, it means it's a loss. So year 2 is 1 in brackets, so to be 1,000. So negative 1,000, meaning that year you made a loss. Then year 3 is 2,000. Year 3 is 2,000. But then they also gave you the residual value. So you put it here. So the residual value is the value that you are getting at the end of its useful life. So you just put it here. You don't need to put 4 here. Then we have the depreciation. So depreciation is constant. So for year 1, you have 31,000. Then year 2 is also 31,000. Then year 3, 31,000. So the depreciation doesn't change. So like I said, to get the cash flow, it's going to be the profit plus the depreciation. So let's calculate it for all the years. So for year 1, the profit is 29,000 plus 31,000. So our cash flow is 60,000. 60,000. Then year 2, we had a loss. So we are going to subtract this from this. So when you take 1,000 from 31,000, straight away you are going to get 30,000. Then year 3, we had 2,000. So it's going to be 2,000 plus the 31,000. Let me bring it up here. So that's 0. That's the 31,000. So for year 3, it's going to be 2,000 plus the 31,000, which is going to give you 33,000. Yeah, so for year 3, the cash flow is going to be 33,000. So we don't even need to add the residual value, because at the end of the day, for payback, it only looks at when you are going to make your money or how fast you are going to make your money. The residual value you don't need to add. You can decide to write it, but it's not really necessary. So now we have the cash flow for plant 1. So let me just write it here. So this is for plant 1. Now let's go to plant 2. So let me just clean this side. So let me write the cash flows here so that you guys see it. So cash flow for plant 1. So we have 60,000, then 30,000, then 33,000. So this is year 1. So let me just do a year. So year 1, 2, and 3. So the cash flow. So I'll just do it as CF. So these are the cash flows for plant 1. So now let's calculate the payback period for plant 1 before we go to plant 2. So for plant 1, the payback period is going to be 60,000. So for plant 1, the first year you made 60,000 cedis and the cost was 100,000. So we can just put it somewhere here, or let's put it at the top. So now you can calculate for the payback period. So here will be cumulative cash flow. which is the same as the payback period. So we invested 100,000. So let me just make here 100,000. 100,000. This is what you invested, 100,000 cedis. These are the cash flow. So what you actually get it. So for year one, you got 60,000 cedis. You get it. We invested 100,000 and we got 60,000 cedis. So you mean now we are left with 40,000 cedis to get. We invested 100,000 and now we've got 60,000. So how much you are going to left with is what you are going to write here. So 40,000. So it's just going to be 100,000 cedis minus the 60,000 and we've got 40,000. Now year two, you got 30,000. But remember, you are left with 40,000. So you take the 30,000 cedis from how much you are left, which is the 40,000 cedis. Then you're going to get 10,000 cedis, which is in year two. 10,000 cedis. So it's now you're left with 10,000 cedis. You get it to pay. Because year one, we got 60,000 cedis. Year two, we got 30,000 cedis, which is 90,000 cedis. And we invested 100,000 cedis. So we are just left with 10,000 cedis. But for the year three, we got 33,000 cedis, which is way more than what we need. We only needed 10,000 cedis to get 100,000 cedis. The payback only looks at how fast it's going to take you to get your money. Do you get it? So since the 33,000 cedis is more than what we want, it's going to be how much you need to get, which is 10,000 cedis. You need 10,000 cedis right now to get your 100,000 cedis over how much you are getting that year, which is 33,000 cedis. Then times 12. The 12 represents months. You get it? So the thing is that it's not going to take a whole year for you to get a 10,000. It will take a whole year to get a 33,000. But you only need 10,000. You get it? So it's going to take less than a year. So you are going to calculate how many months it's going to take. So it's going to be, you are getting 4. So 4 months. You get it? So it means for plant one, the payback period. So we start counting from here. Here is year one, then year two. Here it didn't take us 1 full year. So it's not up to 3 years. 4 months. So 2 years, 4 months. You get it? That's what it means. So for plant one, the payback period is equal to 2 years, 4 months. That's how you calculate for it. So anytime you reach a point where you're getting more than you have or more than you need, it will be how much you need to get over how much you are getting that year times the 12. Then calculate the number of months. So this one, we started 1, 2, then 4 months. So for plant 1 is 2 years, 4 months. So let's clean everything. So now we are going to calculate the payback period for plant 2 to see which one will give you a faster payback. Say yes. So this one is for plant 2. So let me write it here so that you guys see it. So for plant 2, we have the profits. Let me write the profits, the annual profits. And year 1 or year 0, you have 60,000, which is how much you invested. So you invested 60,000 cedis. Then year 1, we got 18,000 cedis. 18,000 cedis. Then year 2, we got a loss, which was -2. So anytime you see anything in brackets, it means it was a loss, which is -2,000. So then year 3, you got 4,000. Yes. So these are the profits. Now we are going to add the depreciation. We've already calculated for the depreciation. So the depreciation is 18,000. So every year, 18,000. 18,000. 18,000. So now the profits plus the depreciation will give you the cash flow. So cash flow. So for year 1, it's going to be profits plus the depreciation, which will be 18,000 plus 18,000. So you're getting 36,000 when you do it on the calculator. Then, okay, let's just do it. Then for year 2, it's going to be this plus this, which is -2,000. So you just take the -2,000 because this plus this at the end of the day will still give you. So -2,000 plus 18,000. You are getting 16,000. Then year 3 is going to be this plus this, which is 4,000 plus 18,000. So 4,000 plus 18,000. Getting 22,000. Yes, so that's the cash flow for year 3. So now we've got our cash flow for plant 2. So now we can calculate the payback period. So let's calculate the payback period for plant 2. So let me bring the cash flow here. So the cash flow. So we invested 60,000. And put it in brackets so I don't get confused. Then year one, we got 36,000. Then year two, we got 16,000. Just right here. Then year three, we got 22,000. So let me clean that part. So I will now calculate for the cumulative cash flow. So for the cumulative cash flow, it's going to show us how much we are left to pay at every point in time. So that we'll be able to calculate the payback. So we invested 60,000 cedis, and year one we got 36,000 cedis. So we need to subtract 36,000 from 60,000 cedis to see how much you are left to pay now. So we are going to do 60,000 minus 36,000. We are getting 24,000. So meaning that out of the 60,000 cedis, we've paid 36,000. Now it's left 24,000 for us to recover our money. Now year two, we also got 16,000. So we'll take the 16,000 from how much we are left to pay, which is 24,000. So it's going to be 24,000 minus 16,000. We are getting 8,000. So now it's left with 8,000 for us to pay. You get it? Now for year three, we are getting 22,000, but we need only 8,000. You get it? We've got 36,000 and 60,000. We need only 8,000 to reach the 60,000 which we invested. We are getting 22,000, which is more than what you need. So you are going to do how much you need, which is 8,000, over how much you are getting that year, which is 22,000, times the number of months, so that we know the month it took us, because it's taking us the whole year to get 22,000, but you don't need 22,000. So obviously it's going to take some months to get us the 8,000 we need. So let's calculate it. So 8,000 over 22,000 times 12. I get it 4.36. So 4.36. 4.36. So now I'm going to calculate the payback period. So we start from here. So year one, then two. Then for the year three, we didn't use the whole year. You get it? It took some months, which is 4.36 months. That's what we just calculated here. So here is months. So meaning that for plant 2, the payback period is equal to 2 years. Because here we took the whole year, here we took the whole year, but here was months. 2 years, 4.36 months. That's what it means. So for plant 1, it took us 2 years, 4 months, but plant 2, 2 years, 4.36 months. Meaning that plant 1, it took a slightly shorter time. So the question didn't ask you which one you should choose, but assuming it asked you, you would have taken plant 1 over plant 2 because it took a shorter time. This one took 4.36 months, so plus some additional days, but this one just took 2 years, 4 months. You get it? So yes, that's how we calculate the payback period. So now we are done with the payback period. We are going to go to the net present value. The net present value. So the net present value is how much you are getting for the investment, or how much you are getting from the investment in present day. You get it? So assuming someone is able to give you the money you are going to get for the investment today, how much it will be worth now. So if let's say in year 2 you are getting 30,000 cedis, year 4 you are getting 60,000 cedis and all that, I want to see if how much it will be worth today. You get it? So the present value, that's about net present value. So for the net present value, we're going to find the discount factor and the discounted cash flow. So you're going to use the cash flow. You're not going to use the annual profit. And we've already solved for the cash flow. So you're just going to repeat it. So we'll start with plant 1. So for plant 1, so we'll do it, or we can just do both of them at the same time. So plant 1 and 2. So let's start with, so we have the year, then 0, 1, 2, 3. Then we have the cash flow for plant 1. Then for that one, you invested 100,000 cedis. So when you see year 0, it represents how much you invested. You get it? So once you see, it's even already stated in the question, so 100,000 cedis. Then year 1, we already calculated for the cash flow. Year 1, we got 60,000 cedis, which we already calculated for. Then year 2, we got 30,000 cedis. Then year 3, we got 33,000 cedis. So now we've got the cash flows, but these are future values. Do you get it? So now we want to see the present values of all of them. So we find the discount factor. And the discount factor is from the present value formula. Do you get it? So when we multiply the discount factor by the cash flow, we are going to get the present value. The formula for present value is the future value times 1 plus r exponent negative n. So this 1 plus r exponent negative n is the discount factor. And these are the future values. So we want to multiply this by this so that we get the present values. You get it? So for the discount factor for year 0 is going to be 1 because it's already in present value. So when you multiply this by this, you get the same thing. You get it? So always take note for year 0, discount factor is always 1. Then year 1 is going to be 1. This is the formula is here. So 1 plus r. What was the rate they gave us? Okay, so they said the cost of capital is 10%, meaning the rate is 10%. So it's going to be 10 over 100. Rate you always divided by 100. So 10 over 100. We are getting 0.1. Get it? Exponent negative n. So this is 1. The n represents the year. So exponent negative 1. So for year 2, it's going to be the same thing. 1 plus 0.1 exponent negative 2 because we are in year 2. 1 plus 0.1 exponent negative 3. So just 1 plus the rate, then the number of year, you put negative there, the exponent. So now let's see what you are getting. So let's start with the first one. So 1 plus 0.1 exponent negative 1. We are getting 0.9. 0.9. Then the second one, 1 plus 0.1 exponent negative 2. We are getting 0.83. So you can do it to 4 or 3 decimal places as well. You get something similar at the end of the day, 0.83. Then 1 plus 0.1 exponent negative 3. You're getting 0.75. 0.75. So this is our discount factor. You get it? So mean when we multiply the discount factor by the cash flow, we are going to get the discounted cash flow or the present values. So yes, so since we've already done it, I can clean how we got it. So let me clean this side. So let me put the values here. So you have 0.9, 0.83, and 0.75. Now the discounted cash flow. The discounted cash flow or the present value, in some books you see present value, is the cash flow times the discount factor. The cash flow times the discount factor. And 100, so the first one is 100,000 times 1. That one is still going to be 100,000. It doesn't change because it's already in present value, which is the cost, how much you invested. So that one is present day. And the second one is 60,000, or year 1 is 60,000 times 0.9. So 60,000 times 0.9. We're getting 54,000. 54,000. And the second one, 30,000 times 0.83. 30,000 times 0.83. We're getting 24,900. So 24,900. Then the last one is 33,000 times 0.75. 33,000 times 0.75. We get it 24,750. 24,750. And mind you, this particular question today, they give us a residual value. Do you get it? And I said the residual value is the value you are getting at the end of its useful life. So at the end of year 3, the value that you are getting. Do you get it? And that one is 7,000. So it's 7, but 3 zeros. So 7,000. So at the end of year 3, so you just put it under year 3, 7,000. And the discount factor is going to be the same thing as what we got at year 3. So it's going to be 0.75 because also in year 3. So to find the present value of the residual value, how much is going to be worth now? It's going to be 7,000 times 0.75. So 7,000 times 0.75. You are getting 5,250. 5,250. So to get the net present value of plant 1, we are going to add all the cash flows plus the residual value minus how much we invested. So we are going to see how much you are going to get from it. Because we want to see how much you are going to get from it now in present day. So when we add all of them, so let me just do it somewhere here. So we have net present value of plant 1 is equal to the cash flows plus the residual value minus the 100,000. So let's calculate for it. So we have 54,000 plus 24,900 plus 24,750 plus 5,250. I'm getting 108,900. So 108,900. This is for the cash flows. So we have to subtract the cost from it so that we see what you are getting in present day. So so we have 108,900 minus 100,000. You're getting 8,900. So our NPV per plant 1 is 8,900. Depending on the approximation you use, you might get something higher or lower, but it should be very close. At least it shouldn't be more than 10,000 or maybe less than 7,000. It will be very close. Yes. So the net present value for plant 1. Now we have to calculate the net present value for plant 2 as well. So we can just continue with it. So for plant 2, we use the cash flows. So cash flows for plant 2. And for plant 2, when we calculate the cash flows, we got, so we invested 60,000 cedis. Then year 1, we got 36,000 cedis, which is what we calculated for. So we calculated the profit up plus the depreciation, what we calculated for. Then year 2, when we calculated, we got 16,000 cedis. 16,000 cedis. Then year 3, when we calculated, we got 22,000 cedis. 22,000 cedis. And the question gave us a residual value for plant 2. Okay, also give us a residual value. So that one is 6,000. 6,000. So we can put it here. 6,000. So now we can straight away find the discounted cash flows. So it's going to be the CF times the discount factor. So the first one is 60,000. Because it will be this times this, 60,000 times 1. So you can just put it in brackets. Also subtract it. So for year 1, it's going to be 36,000, which is this 36,000 times 0.9, which is 32,400. 32,400. Then for year 2, it's going to be 16,000 times 0.83. 16,000 times 0.83. You have 13,280. So 13,280. Then for year 3, it's going to be 22,000 times 0.75. You have 16,500. 16,500. Then the residual value is 6,000. So that one is going to be in year 3. So to be 6,000 times the 0.75. So 6,000 times 0.75. You have 4,500. So all these are the future values, but in present day right now. So in year 1, you're going to get 36,000, but assuming you are going to get it today, it's going to be 32,400, the same as all the years. So that's what it means. For year 1, we have 32,400. For year 2, we have 13,280. Then year 3, we have 16,500. Then year 4, we have 4,500. So in add, you are getting 66,680. So let me put it here. So NPV for plants 2 is equal to 66,680 minus the cost, which is 60,000. So when you subtract it, you are getting 66,680 minus 60,000. You are getting 6,680 cedis. That's here if the question is in cedis. So yes, it's in cedis. So 6,680 cedis. So now we've calculated for the net present value for both of them, the plant 1 and plant 2. And now the C says you should calculate for the internal rate of return. And if you want to calculate for the internal rate of return, you need two net present values, a positive and a negative. Now you realize that for this one, the net present values, all of them were positive. So once you solve and get a net present value which is positive, you have to take another rate to get another net present value which will be negative. And if you want to do that, you have to take a higher rate to get a negative net present value. Higher rate. So this one we use 10%. So I'm going to take 20%. You can take 25%, 30%, anything higher. So that we'll get like an average of it. Do you get it? So we are going to do the same thing for 20%. This one there was a discount factor for 10%. So we are going to do the same thing for 20%. So let me clean. Yes. So this was for 10%. So I'm going to clean this one. I want to affect the discounted cash flow as well. The discounted cash flow as well. See, yeah. So for the discount factor now it's going to be 20%, not 10%. So you're going to use 20%. So remember when it was 10%, we did it 1 plus 0.1 exponent negative n. But this one is going to be 20%. So it's going to be 1 plus 0.2 because 20 over 100. So not 1 plus 0.1, 1 plus 0.2 exponent negative n. So for this one to year 1 is going to be 1 plus 0.2 exponent negative 1. Exponent negative 1 because it's year 1. So when we do it on the calculator, we are getting 0.83. So the second one to 1 plus 0.2 exponent negative 2. Exponent negative 2 because the year is 2, so year 2. So 0.694. Then for year 3, it's going to be 1 plus 0.2 exponent negative 3. We have 0.578. So you can do 0.579 because it's 0.5787. So 3 decimal place 0.579. So now we have our discount factor. So you need to multiply this by this to get the discounted cash flow. So for year 1, it's going to be 60,000 times the discount factor, which is 0.83. So times 0.83. We are getting 49,800. So 49,800. Then for year 2, it will be 30,000 times 0.694. So 30,000 times 0.694. We're getting 20,820. So 20,820. Then for year 3, you are getting 33,000 times 0.579. 0.579. You are getting 19,107. So now we are done with the discounted cash flow for plant 1 using 20%. So now we're going to go to the plant 2 using the same 20%. So we'll just multiply this by this because it's the same rate. So it's going to be the cash flow times the discount factor. So we have 36,000 times the 0.83, 0.83. So you have 29,880. 29,880. And we have 16,000 times 0.694. So 16,000 times 0.694. We have 11,104. 11,104. Then we have 22,000 times 0.579. So 22,000 times 0.579 times 0.579. We have 12,738. So 12,738. Oh, we even have the residual value. So we didn't do it for this one. So let's do it for this one as well. So this one, the discount factor is also going to be 0.579 because it will be the third year. So it's going to be 7,000 times 0.579. So 7,000 times 0.579. You're getting 4,053. So 4,053. So for this one too, it's going to be the discount factor, which is 6,000 times the 0.579. So 6,000 times 0.579, getting 3,474. 3,474. So now we are done. Now we're going to get our net present values, the new net present values using 20%. These were the net present values when we were using 10%. 10%. So new net present value using 20%. So let me write it somewhere here. So the net present value is going to be all this minus the 100,000. So 49,800 plus 20,000. So this is for plant 1. So 20,820 plus 19,107 plus 4,053. So you're getting 93,780. So net present value. So net present value into brackets plant 1 using 20%, 20% is equal to 93,780. So that's the total of all this, minus the 100,000, which is the cost. So please don't forget it anytime you are doing it. So minus 100,000. So 93,780 minus 100,000. 93,780 minus 100,000. Negative 6,200. Negative 6,220. Sorry. So yeah, so that's the net present value for plant 1 using 20%. So now we go to the net present value for plant 2. Using the same 20%. So net present value for plant 2, we are going to add all the cash flows minus the costs. So we have 29,880, then plus 11,104, plus 12,738, plus 3,474. Then we are getting 57,196. So 57,196 minus the 60,000. So 57,196. So let me just put here. So 57,196 minus the 60,000, which is the cost. So what do we get? So 57,196 minus 60,000. Then negative 2,804. Negative 2,804. So now we've got all the net present values. So for plant 1, using 20%, we got the negative, which is negative 6,220. Then using the 10%, you got the positive. So for the plant 2 as well, using 10%, you got the positive, and using the 20%, we got the negative. So now we can use this to find the internal rate of return. So now let's find the internal rate of return since we've got all the net present values, the positive and the negative. So we can clean the table now. So to find the internal rate of return, this is the formula. The formula for the internal rate of return. So the formula is A plus the net present value of A over the net present value of A minus the net present value of B times into brackets B minus A. This formula is also called the linear interpolation formula, and I'm going to explain it. So the A here is the rate that gives you the positive NPV. So the NPV for plant 1, we have a positive and a negative. So the rate that gives you the positive is the A. And for plant 1, so you are starting with plant 1. The rate that gave us the positive NPV was 10%. So it will be 10 plus the net present value of A. So the net present value of A is what the 10% gives. So the 10% gave us 8,900. 8,900 over the net present value of A again. So 8,900 minus the net present value of B. Net present value of B is the negative NPV. So for plant 1, the negative NPV is this one, which is negative 6,220. So into brackets, negative 6,220. Negative NPVB times. So the B is the rate that gave you the negative, and the rate that gave us the negative was 20% for plant 1. Then minus A, which is the 10. So minus 10. So now I'm going to punch everything on the calculator and see what we get. So we have 10 plus a fraction with the numerator 8,900 over 8,900 minus into bracket negative 6,220 times into bracket 20 minus 10. And when punched on the calculator, we are getting 15.88. So you can just do it 15.9%, which is almost 16%. So you might get about 16 point something if your approximations are different, or 15 point something. So yes, the IRR for plant 1 is 15.9%. So let me just write it here. The IRR for plant 1 is equal to 15.9%. Now let's do for plant 2. So for plant 2, you're going to use the same formula, and A is the rate that gives you the positive value. So for plant 2 as well, this is the negative value and this is the positive value. So the rate that gave us the positive was 10%. So A is also going to be 10 for here. Then plus the positive NPV, which is NPVA. So the positive NPV was 6,680. 6,680 over the MPVA again. So 6,680 minus the MPVB. The MPVB is the negative MPV. So for plan 2, the negative MPV was this one. So minus into brackets 2,804. It's already minus here and another minus. So we can plus. Then times. So B is the rate that gave you the negative value. And that was 20%. It gave us negative. So 20. Then A is already here. So the rate that gave us the positive, which is the one that gave us the positive here. So minus 10. So you're also going to punch everything on the calculator to see what we get. So we have 10 plus 6,680 over 6,680 minus into brackets minus 2,804. So always this side you're going to get negative, so that will become positive. Then times into brackets 20 minus 10. So you are getting 17.04. So let me just do 17%. 17%. So the IRR for plan 2 is 17%. So the IRR for plans 2 is 17%. So we are done with the C, the IRR. So this is for plan 1 and plan 2. Now the D says recommend the plan to purchase and explain why MPV should be considered over IRR. So recommend the plan to purchase, you use the MPV because MPV is considered one of the best measures of profitability. So we use MPV, and the MPV, plant 1's own is higher than plant 2. For plant 1, we got 8,900, and plant 2, we got 6,680. We don't use this one because these ones are negative, so we use this one. So since the MPV of plant 1 is higher than that of plant 2, we say plant 1 is the better investment. So plant 1 should be considered over plant 2. And it also says, explain why MPV should be considered over IRR. So you can say that the MPV measures the actual return you are going to get, the actual profit you are going to get. But the IRR only measures the percentage. So meaning it's an estimate. So it's not guaranteed. And the IRR too is where the MPV becomes zero. You get it. So it's more like where you break even. But the MPV shows you the actual profit you are going to get. So hence MPV will be the better option. Yes. So that's all for number 3. And that's all for today. In the next video, we are going to solve the other questions, which is question 4, question 5, and 6. Then the next one will solve the 7 to 11. So I'll see you in the next video.